Welcome, Calculus AB. This is lesson 1-2, functions, inverses, and graphing adjustments. Let's begin. So, what is a function? Again, this is a lot of review. So, a few vocab words. A relation is sets of ordered pairs. That means x, y's. So when you have two numbers, they form a relation. That's points. A function is a relation where each x value, there is only one y value. And sometimes we can prove this through the vertical line test. So if you graph something, and if you ever draw a vertical line, it crosses it more than once, it's not a function. All right? An example of that would be number 2. I'm just skipping ahead. If you draw a vertical line like that, it crosses 2 times. So number 2 is not a function. So no, it's not a function of x. Domain is your x values. Range is your y values. So determine, is this a function? When I say x plus y equals 1, yes, this is a function. This is the same thing as y equals negative x plus 1, which is a line. Lines except for vertical lines are functions, yes. 3, y equals negative x squared plus 1. This is also a function, yes. This is an upside down parabola, and that's going to form a function. Every x value or every y value, there's only no x value, there's only one y value. 4 is not a function, and this is why. So for every x value, you could have more than one. There's certain x values where you could have more than one y value. Here's an example. What if x was, what's a good example for this one? X was 1. No, x was 0. If x equals 0, then you have y squared equals 1. Well, this is true when y equals 1 or negative 1, because negative 1 squared is positive 1. So this x has 2 possible y values. So there's an example of where it is not a function. And because of that, it's not a function. Okay, so here's some examples of functions, function composition and operation. So f of x is this, g of x is this. This is important stuff here. So f of 10, if f of x is this, when I say 10, that means plug in 10 for x. So it becomes 3 times 10 instead of 3 times x minus 1, which is 30 minus 1, which is 29. Okay, this is weird. G of x plus delta x. Well, this means you plug this whole thing in for x of this equation, which happens right here. So it's going to be g of x plus delta x turns into x plus delta x squared. So instead of x squared, it's x plus delta x squared. Whatever's in here, even if it's more x's. All right? And you could expand this, but you don't have to. That's the answer. This is called composition. So g of f of x. You do the f of x. What is f of x? Well, f of x is 3x plus 1. So this is actually just g of 3x plus minus 1. So that means you're plugging in 3x minus 1 for the x. So that's going to be 3x minus 1 squared. And you can distribute that if you want to. So you get 9x squared minus 6x plus 1. F of g of x, this is also function composition. It's just a different way of writing this, but these are actually flipped. That's like f of g of x. So g of x in this case, so that's the same as x squared, so f of x squared. I'll be plugging in x squared for this x right here, so it becomes 3 times x squared minus 1, which is just 3x squared minus 1. Functions. Determine domain and range of each function. So on this, a domain is all your possible x values. So what's going to be weird is when you square root or when you divide by numbers. You remember you can't square root and get a negative coming out, and you can't divide by zeros. So what x values would this be a negative inside of here? So this has got to be 0 or above. So I can say in my domain, my x has to be greater than or equal to 1. Because if it equals 0, this becomes 0 minus 1, negative 1. We can't do square root of negative 1. That's bad. So domain is x is greater than 1. Your range, your possible y values. Now again, square roots can't be negative, so it's 0 and above. So y has to be greater than or equal to 0, because everything has to be bigger. For this one, your domain, it's what x values make this divide by 0. It's 2. So I can say x is not equal to 2. That's a valid thing. That means everything else is okay except for 2. Your range is what y values can it be. And this can be everything except for one value. When you have 1 over a number, that means you can never be 0. So y does not equal to 0 because you can't make 1 over something equal 0. Looking at this graph, you have an asymptote here, and you got an asymptote here, and you got an asymptote here. So your domain is your x values. Well, it can't be this one or this one. This x value is 0. So x does not equal 0, or let's say this is 2. And your range is your possible y values, so y can't equal, it never touches 0 up here, but it also, like, it touches 1 but never gets above that. So, I mean, it goes above that, but it's like nothing between 0 and 1. So what I can say y has to be less than negative. So I can do like the domain. I can do the notation I did before, from negative infinity to 0, and we do curved because we're not including it, and then we do hard bracket from 1 to infinity because we do include this one because it's touching right here. All right. Inverse functions. Inverse functions is, so we have this idea of a one-to-one function. You know how before they had to pass the vertical line test? If it also passes the horizontal line test, a function is one-to-one. That means every x value only has one y value, and every y value only has one x value. So like a line function, like a slanted line, is going to be like that because every x value has its own unique y value. Parabola would not be one-to-one because it doesn't pass the vertical line test because certain y values have multiple x values. So this is important for something called inverse functions. So inverse functions, you can find those by switching the x and the y. And the notation kind of looks like this, f to the negative 1 of x. And that's sometimes confusing because this usually means like reciprocal sometimes. But if you see it written like this, this is inverse function. So x and y are switched, and then you find the inverse functions. So let's do some examples of what that looks like. And that means like you flip the x's and y's in the graph. Which of the relations in examples 1 to 4 is an inverse function? Let's go all the way back. Okay, so which of these is an inverse function? It's a lot easier if you can just graph these. In fact, I don't like these. So is this an inverse function? Is a function with an inverse function. So it means, can you like flip them and still be a function? So if it's an inverse function, if you can flip the x and y and still make it a function. If I flip the x and y, this just becomes y plus x equals 1. And yeah, that's still function because I can write that as y equals negative x plus 1, and it's just a line. Sweet. Does this have an inverse function? Well, it's not even a function, so no, it doesn't pass the vertical line test. What about this one? Well, so it'd be x equals negative y squared plus 1. This is not going to be an inverse function. This is not going to have an inverse function because at certain x values could have multiple y values. So we say no. Number 4 here, so if we go y plus x squared equals 1, does this have an inverse function? Yes. This is a function because that's y equals negative x squared plus 1. So it has an inverse function, but this was not a function. It's kind of confusing. Ask questions in class. All right, so we did those. Find the inverse of this function. So first thing you want to do to find an inverse, this is more like what we're going to expect, is just change the f of x to a y. Oops, it's a cubed. And then what we're going to do is we're going to flip the x and y. So x equals 2y cubed minus 1. Now let's solve for y. So the first thing you want to do is add 1 to both sides. So x plus 1 equals 2y cubed. Divide by 2 on both sides. So you're going to get x plus 1 over 2 equals y cubed. And then you're going to actually cube root both sides. So cube root both sides. When you cube root a cube, that just becomes y. And then it's just the cube root of x plus 1 over 2. And you can leave it like that. Don't try to change it. And we could, use function notation. Inverse function of x equals the cube root of x plus 1 over 2. Why not? Piecewise functions. So it's a function that has different pieces. So look at this. This is piecewise because it's got this piece and this piece. Actually, this piece and this piece and this piece. It's 3 different pieces of functions. And this is what it looks like in algebraic form. So when x is less than, this is like the domain, right, of this part of the function. So when x is less than 0, you just do the y equals x function right here, which is just a line. When x is between 0 and 1, we do 2 minus x, which is like a line going down like this. And when x greater than 1, you do x squared. It's like a parabola shape going up like this. This is how you get a piecewise function. So this happens in calculus. We'll do a lot more with this later. Let's graph a piecewise function. So the absolute value of x function looks like a v. And when x is greater than 1, you can do absolute value. So it usually looks like this. Let's do this as a dotted line. But since it's only when x is less than 1, it's only going to happen on this line I'm filling in. Perfectly straight, right? Yeah. Okay. Now, when you have x plus 2, usually the graph of x plus 2, y equals x plus 2, that would be your slope intercept of this. And slope is 1. Usually it would be like a line like this. But what happens is when x is greater than 1, that's the only time we use that. So we're using it right here. So this is your piecewise function. Notice I did an open circle here and a closed one. That's because the point actually jumps up here. Because it's when it's less than 1. You don't actually include 1 for the top. Your domain, all your x values, is all real numbers because x values on the left side go to left forever, and the right side, they go to the right forever. So we can always say all real numbers. Sometimes I abbreviate that ARN. That's fine. You want to spell it out for the AP test, though. Your range, your y value. So what's your lowest y value? It's this guy. And then it goes up forever. So I can say my y is greater than or equal to 0. Zeros. So zeros are where x values where the y equals 0. I think I did that with graphing last section. That's weird. Conventionally, zeros are written with single value. So you can represent zeros as like an ordered pair like this, or you could say x equals 2 or x equals 5. These are equivalent, like these are zeros. It's just this is in point forms, and this is ordered pair forms, and this is just, hey, it happens when x is 2 or x is 5. So how do you find zeros? Well, y equals 0, which is your f of x. So let's do this with a calculator. I'm going to say 0 equals x squared minus 3x minus 4. It's quadratic. You can factor it. Now, some of you might know like this x thing, and then you say blah, blah, blah. What numbers multiply negative 4, add to 3? That's going to be negative 4 and positive 1. So your factored form is x plus 1 times x minus 4. And you have to solve each of those factors, so your solutions are x equals negative 1 from this one and positive 4 from that one. Those are your zeros. Now in 6, where are your zeros? Now zeros only happen when you have a fraction when the top of the fraction equals 0. And the bottom also is not 0. So when does the top equal 0? Well, x squared minus 4 equals 0. Maybe you can eyeball that and say it's 2 and negative 2. Or you realize this is difference of squares, and you can factor as x minus 2 times x plus 2 equals 0. Your solutions are x equals 2 and negative 2. All right. Parent graphs. So these are good things to memorize. These are just kind of typical graphs you see, and sometimes we put them in different form. This is a good one to know. Line, parabola. Knowing what a cubic looks like, this like S thing. This is sometimes okay to know. The fourth root is kind of like a wider parabola. This is really important to know. The square root function is kind of like there's a point right here and then it just kind of swirls off like a sideways parabola with half of it cut off. This one I don't think happens too much, and neither does this one. Absolute value, yeah, I should know it's a V shape. Yeah, inverse function, this will happen a lot. This is good to know. Sort of on this one, and I don't know if you'll need to be familiar with this. Everything I circled is kind of important. The rest, sort of. Okay, a lot of adjustments you can make to graphs. Again, I don't think a lot of this pops up. What's important to know is if you put a negative, it reflects it on the x-axis, so it kind of like, it just like rotates on the x-axis, go to the other side, so it goes to the bottom side of it from the top. So that might be important. reflecting on the y-axis, so like moving from left to right or right to left. Oh, this one is actually important, so I'm going to really circle this. So when you have like a plus number on the outside or subtracting a number, it shifts the graph up or down. And this one right here, if you're adding a number with the x, it shifts it left or right. Those are important ones. Yeah, I know. Multiplying number outside here stretches. Inside it squeezes, and some absolute values. But like these 3 and 4 and possibly 1 or 2 are the actual ones that you should get comfortable with. So let's take an example. This is the function f of x right here. And you might not have done something like this before, but like, what does each of these translations of this function do to this function? So when I say an x plus 2, this is going to move it to the left 2 units. So I got this parabola and then a line going down. So it moves to the left, it's going to do like a parabola and a line going down. That's what it's going to look like. Now, negative x plus 2, the negative is going to flip it. So it kind of flips it upside down like this. But the plus 2 shifts it all up. So what I actually have as a function looks like this. Shifted it up 2 units after it flipped it. This one, the negative x times 1/2. So the negative x is going to flip this on the y-axis right here. So it's going to like do this. And it's going to look like this. But the 1/2 kind of shrinks it. It squeezes it. So actually you have a function that it just doesn't go up as high or down as high. It kind of does this instead. So it squeezed things in a little bit more, pushed them both ways. This one, absolute value f of 2x. So the 2x is going to make it skinnier. So it kind of like pushes it in. So in this case, a 2x is going to make it do this. And the absolute value actually makes it so anything that goes negative flips up to the top. So your real function is going to look like this. This, and then it's going to go down. But then this part's going to go back up. Just like that. Now, when you put an absolute value inside of here, it means you can never use the left-hand, well, you can use the left-hand side, but it's going to mirror the right-hand side. So right-hand side stays the same, because if you do absolute value positive, nothing changes. So do that line. Now, on the left side, instead of doing the parabola, it just mirrors the line, because it's kind of just mirroring what you're doing on the positive side. Okay, that's it.